Okay guys, disregard the last video except for the first part of it. I screwed up a little bit because I wasn't thinking. Okay, so let me re-explain some stuff. So the first things first. Trapezoid. Trapezoid is this little figure which has two parallel sides. And it has two little legs right here. Um, I made a little mistake. So these two don't always equal, so I'm going to scratch those out. That's what the mistake was. I kind of messed up on that. But what's special about trapezoids is this: is that if you have the little angles right here, 1 and 2, the angles that are like this, and the angles like this, add up to 180. So like 1 and 2 add up to 180, 3 and 4 add up to 180. So if you have something like if you know this one's 36, if you know angle 2 is 36, how would we find angle 1? Well, we know angle 1 plus angle 2 equals 180. So because we know that we can take 180 and subtract 36, and we would get 144. So we know like angle 1 would be 144. Same thing for 3 and 4. If I knew one of the angles, all I gotta do is take 180, subtract the angle I know to figure out the other angle. Now, for the most part, 2 and 4 do not add up to 180. 1 and 3 do not add up to 180. Only 3 and 4 and 1 and 2 add up to 180. There's a special trapezoids in which they do actually add up to 180, but this is not the case. Um, Next part. So, when we're looking at something like this is a trapezoid again. There's three things that you need to know about the trapezoid. First is base 1 is always the bottom, base 2 is the top, and the height is always the thing that goes up and down. Never use the sides. I'm going to put some in there that use length of sides on there, but never use them as your information to do this problem. So once again, it's going to be 1/2 the height, meaning how far it is from the bottom to the top, times base 1 plus base 2. In this case, we have 8, 10, and 4. Our height is 4, our base 1 is 10, our base 2 is 8. So what we do is you take 1/2 the height, 4, times base 1 plus base 2. So that's base 1 is 10 plus base 2 is 8. So it's 1/2 4 times 18. Because you just added these two together. And if you actually did that, you'd end up with 36. This is the two things you need to know about trapezoids, is that the angles on the left, the angles on the right, they add up to 180, and how to figure out your area formula. Now kites, they have a little bit more. Okay, so kites are significant by this. So, the two top lines are always congruent. These two bottom lines are always congruent. So these are always congruent. So we know a couple things. All kites will be divided like this. They'll have two diagonals. These are called diagonals because of the fact that they do one thing, and that is they're perpendicular bisectors. Okay, what that means is that they create right angles at where the two diagonals meet. So it's a perpendicular bisector. Now, also bisector also means that it cuts something in half. So technically, it cuts this line in half. So as you can see, just from this, you'll be able to tell that that these two triangles are congruent to each other, and these two triangles are congruent to each other. because that's how kites work. Now, another special thing about kites is that these two angles right here, so angle, I'm going to call this angle 1, I'm going to call this angle 2, they're congruent. So they are the same angle. However, 3 and 4 are not the same angle. So what's good about this is that if you have an angle here and if you angle here, let's say you had an angle 37 and it had an angle, I don't know, 25. Because we know all these triangles are congruent to each other, these two are congruent to each other, these two are congruent to each other, we would know that like this would also be 37, this would also be 25. So if I wanted to find the whole angle there, I would figure out, okay, well, this would have to be 62, and this side would also be 62. Because the fact of the matter is that you have 37 and 25, they make up this whole angle. These two smaller angles make up this whole angle, so you'd add them together, and you would get 62. So if I gave you this angle, and I gave you this entire angle up here, you should be able to find this last angle down here by just doing normal subtraction. Because think of it, like let's say we said angle 3 was, I don't know, 93. Okay, so we know that the angle 1, angle 2, and angle 3 should all add up to 360, because this is a four-sided figure. Remember the n minus 2, since it's a four-sided figure, it'd be 4 minus 2 times 180, which would equal 360. So that's where I got that 360 from. And you take 360 and you subtract 93, subtract 62, subtract 62. If you did that, you would end up with 93 minus 62 minus 62. You'd end up with this last angle down here would be 143. And that's how a kite worked with the angles and stuff like that. Now, how the area formula looks is like this. Okay, so since this is a perpendicular bisector, that means it cuts this little line in half. It cuts this diagonal in half. Our formula is 1/2 diagonal 1 times diagonal 2. So once again, that's going to be 1/2 diagonal 1 times diagonal 2. I'll let you write that down for your sec. Now, a lot of the times they'll give you like something like this, where they'll give you half of this diagonal, and then they'll say this is 3 and 8. They give you those three numbers. This is what you're going to have to do. First, you're going to have to actually measure the entire angle. I'm not the angle, the entire diagonal. So you see how this is 3 and this is 8? Well, this entire diagonal would end up being 11. I'm going to call that diagonal 1. This second diagonal, since it's a perpendicular bisector, like this was bisected, meaning cut in half, if this is 6, that would also be 6. So you would end up with 12 as your second diagonal. And if you ended up multiplying this out, you'd figure out that the answer would be like 66. So those are the concepts between trapezoids and kites. I'm going to give you a couple worksheets to deal with that, but beyond that, you guys should be able to get this, and hopefully just ask questions if you need it.